Now this illustration deals with the 6-circuit breaker or 6 sets of fuses when we're using 2 to 6 disconnects. And notice now we're applying exception 3 to NEC 230.90A. Now one of the things that gave a lot of trouble on this is 230.80. And 230.80 would require the 2 to 6 disconnects that you see to the left of the illustration. Those disconnects could not exceed the ampacity of the conductors. So if you had, say, 250 kc mil, as shown, good for 265 amps if connected in parallel, and that's what we're doing in the quick calc. We have 250 kc mil, each 255 amps, 3 of them connected in parallel. L1 has 3, L2 has 3, and L3 has 3. So we come up then with a total 765 amps when we multiply 255 by 3. And then notice you would have to use there a 750 amp overcurrent device to comply with 230.80 as well as 230.98. So that 230.80 for 2 to 6 switches created a lot of problems. For example, if we had, for example, motor loads, air conditioning, compressor loads, welders, and other type of loads that are in table 240.4G is in gray, notice the size of the mains, the switches with fuses. You have 225, 200, and 250. Now those circuit breakers are rated 200, 175, and 200. Now when those are added together, look at the top of the illustration there. When we add those together, we come up with 1,250 amps, but we only have 765 amps of conductor ampacity. The exception 3 to 230.90A would allow such a installation. It overrides to 230.8. It overrides to 230.98, or excuse me, 230.98, by giving us an exception so we could design those devices larger to allow the equipment to operate, but at the equipment or somewhere in the circuit we have overload protection that really will not allow those devices to be overloaded. But the electrician or the designer, they have to know, as well as the contractor, that those conductors are only good for 765 amps, and you cannot load it more. Now we're using just 4 conductors shown for simplicity's sake, just to make it simple, and it wouldn't look so, you'd have so many conductors terminating, it would really be a very busy illustration. Now notice the 2 to 6 disconnects, as we've previously seen at the very top, are grouped, but we're allowed 2 to 6 by 230.71 and 230.72. The panel board to the right, though, notice I could not have 6 mains and hit the lugs for my service as we could do in the 2017 edition of the NEC. We have to have a main in an individual panel board. We're only allowed 2 to 6 mains where we have individual disconnects, as you see, where we have 3 fusible disconnects and we have 3 panel boards with mains, giving us a total of 6 disconnecting means with 6 throws of the hand. Now, without this exception 1, 2, or 3 being applied, then the total calculated load of 765 that you see in the quick count would have to have a main, as you see in that panel board, of 700 amps. We could round up to 700 amps by applying one of the exceptions. But if not, it would round down to 750 if we applied 230.90A and 240.4 of the NEC. So the note 1 brings it together and basically says that section 230.90A exception 3 permits a 700 amps of overcurrent protection devices rounded up to the next size, say above if you had 690 amps calculated. Now what we're talking about there is the panel board that you see to the right. We have 4 alt conductors parallel 3 times. So 3 times 230 is 690, and that is what the note 1's talking about. If exception 3 is not applied, then we could have the exception 2, this 230.98, and round up to 700 amp. But if you did not apply that exception 2 under the conditions that are listed there, then that 690 amps would have to round down to a 650 amp protective device selected in 240.6A or 240.6A. So the note 2 is saying if you do not apply the exceptions 1, 2, or 3 to 230.90A, the ampacity of the conductors must be protected as Article 240 requires, along with 230.90A. So that's what this figure 6-45 is illustrating, when the overcurrent devices can be size greater than the ampacity of the conductors.